webinar for this Friday morning. Our topic today, how to convert from any 3D CAD to SOLIDWORKS like an expert. My name is Joelle Guénette. I'm a territory manager for the eastern part of North America, and I have with me Michel Cloutier, who is the territory technical manager, and he will be showing you a lot of information today. Before we get going though, just a few keywords on the operation of GoToWebinar. If for some reason this is your first time using the platform, you will notice that there is a window panel on your right-hand side of your screen. You can close that by simply clicking on the orange arrow. It will hide, and same thing, you click back on it, it will come back up if needed. You've got some choices on your audio access. You can do it through your computer. You can do it through your phone. As soon as you click on the phone option, you will get the dial-in number and access code if you wish to do it that way. There are some handouts. So we've got a few different files that are available for you today, and I'll address those in just a minute, but you can download them at any time. And then there's a question panel below that. So if you have any questions as we go through this information, then please don't hesitate and put them in there, and we'll take a quick look at the end and see if anybody has asked anything. So back to the handouts that I just mentioned that are available. There's a number of documentations that have been created. There's a number of surveys that have been held by SOLIDWORKS has done some. Tech Clarity that you see here has did a survey of why people change CAD tools, and these documents are available there. We've also created documents to help in this migration. The traditional hesitations or concerns of changing are the same pretty much for everyone. And a lot of it has to do with what you saw in the little video that we showed before, is what do I do with my data that I have from another tool from before, and we've got documentation to help you through that process, obviously, that are in addition to what we're going to show you today. So before I give over the floor to Michel, just going to take a quick look at why people are doing these changes. Obviously, there's people who want to leave the tool that they have today. That actually happens, right? It's not just the fact that there's they know of something better or something different. They actually want to leave what they have today for various reasons. We'll take a quick look at that. And then why are people then choosing SOLIDWORKS when they choose to leave? We'll look at some results from surveys that we held a few years ago to kind of illustrate the why. So first, why are people leaving their CAD platforms? We're going to start from the bottom of the screen on this one, and most people would think that price is a driver. We're going to save some money, we're going to do it this way. No, it is not the top reason for changing tools, and hopefully this is not how you're approaching it, and not how the people you're working with from a SOLIDWORKS perspective are approaching it either. There's got to be value, there's got to be a reason for you to do a switch. There may have been issues with what you're using right now, right? It may have cost you some time, some money at your company, and this obviously causing frustration within your design team or within the company as a whole. You're looking to fix those, get away from those. You may have customers who are using SOLIDWORKS. It's another good reason why people are switching away from what they have today. Another one is that their suppliers, vendors, all the people that they deal with in your company ecosystem, so outside of your company, are on a different platform. They're not on yours, and obviously it'd be easier if you're all on the same platform. And the top reason is to have a unified and standardized platform on your engineering side. Now, this can expand a whole lot further into the company and where your company goes with Industry 4.0, automation that's coming on board in a lot of places. These are things that companies are looking at more and more, and expanding out of the engineering realm and into the whole company. How do we make this from sales, design, manufacturing, marketing, production, everything, the whole slew? How do we make this all integrated and working together better? And there's 5 reasons for changing in adopting this type of approach. One is to boost productivity overall in your company, reduced costs, improve quality, foster collaboration within different groups within your company that may not traditionally work together. and increase innovation, right? This is how you differentiate yourself on the marketplace is by innovating, by offering something that's different than your competitors. And if you don't have time to do this, then it's going to become a problem. So if you can free up some time by boosting productivity and everything else I spoke about, then you can differentiate yourself. So these are the reasons why people are leaving their CAD companies. Why are they choosing SOLIDWORKS when they do make that decision that we've got to look elsewhere? A number of reasons for that. The overall product portfolio from SOLIDWORKS is one of the reasons. For most, it's not the whole portfolio. It's good to know that it's there, but for most, I would say it's a much higher reason today because data integration and management has become a more key within companies. So SOLIDWORKS product portfolio, I think, has jumped up since we've done this survey. The ability of engineers, of finding engineers with SOLIDWORKS skills is easier in the marketplace. Again, the vendors that use SOLIDWORKS, cost comes up there for people who have adopted it. It's not the top reason why they're leaving, but it could be one of the reasons why they are choosing. Obviously, the customers, if your customers are using SOLIDWORKS, it'd be a good idea if you're on the same platform and having a large footprint in the marketplace. Makes it more likely that your customers are on SOLIDWORKS, or definitely your vendors that I mentioned earlier. At the top of the scale for when we held the survey, people switched to SOLIDWORKS, adopted SOLIDWORKS, and nobody else from a 3D perspective was the product advantages. So we put a lot of time and effort into improving every year our products so that it's better and better. Your productivity goes up. We offer you more. We make it more intuitive. It may not show, but going from 3 clicks to 1 on something that you do on a very, very repetitive basis every day can end up saving a lot of time to companies, and it may be as simple as that. But it never is. So obviously our product advantages are not just in the SOLIDWORKS CAD, but you're going to see some of our other solutions and how they can all talk together, and that makes for a great story and a great reason for going to SOLIDWORKS. So what Michel has done is he selected different reasons or different aspects that we thought you may want to see in terms of what's available, how to do it, and obviously things that he can actually show you within the platform and not just talk about like I have done for the last few slides. So he's going to jump in and show you some of the aspects of the why switch and how to do it properly, switching to SOLIDWORKS, and I'll come back at the end to close. But Michel's been with SOLIDWORKS for 14 years. He switched from 2D to 3D 20 years ago, I found out last week, and has seen CAD evolve from just CAD to a whole lot of other things that surround it, how to reuse your file, and he's going to share that with you right now. So over to you, Michel.
Awesome. Well, thank you, Joelle, and good morning, everyone. So yeah, today we're going to talk about how to work with 3D files coming from other systems, and how to convert these into SOLIDWORKS, but sometimes just reuse them. And this is what I had like on the table for us to do today. First of all, I have a design. It's actually a hybrid design. It has a mix of SOLIDWORKS and Inventor files and assemblies kind of mixed into it. So we're going to see how we can leverage designs from other CAD platforms, 3D CAD platforms. We're going to see how once we got that into SOLIDWORKS, if we can recreate the parametric features. Then we're going to see how we can make changes to files without creating parametric features. Talk a little bit about management and go a little step further beyond CAD. What else can you do with 3D data coming from other systems? So the first thing I want to do here, and before I actually jump into the software, I want to talk about how we can leverage data from another system. So just a quick peek at what I'll be working on today is this tractor lawnmower assembly. And this is most of it is a SOLIDWORKS design, but I actually have bits and pieces of designs from other CAD systems kind of mixed into that. And what I want to do here first is actually to do some changes to that and to add some design, some equipment coming from another system. This one here, for example, the caster wheels are coming from Inventor. So how would we bring in, 3D parts and assemblies from other third parties software back into SOLIDWORKS and reuse that inside my SOLIDWORKS assembly? So let's go ahead and start with that. So let me go back inside of SOLIDWORKS, and one thing I'm going to mention real quick is I'm actually using SOLIDWORKS 2020 that was released just a couple of weeks ago. And this is the full tractor assembly. Now I actually want to focus in this area here. So I'm going to simply show the area of focus and zoom into that area. And you'll notice right away those markups, those are actually done or drawn inside of SOLIDWORKS. That's actually new in 2020. The ability to add markups right inside of your SOLIDWORKS parts, assemblies, and control these markups. Actually, I could save those markups out of SOLIDWORKS in images if I wanted to. For now, I just add them here to kind of illustrate what we want to do. So we want to add the caster wheels, and we also want to make the frame shorter in this area. So let's just go ahead and hide the markups for now and do the first task on our list is to insert the wheels. Now to do that, I'm simply going to say I want to insert component just as I would a regular SOLIDWORKS file. And I'm going to browse to my PDM vault. So if you're actually a PDM user, I'm going to show you another 2020 enhancement, the quick search. So here in 2020, we have a quick search with the history. So I want to search for a caster wheel. I'm simply going to launch the search. I'm going to search not only on SOLIDWORKS files, but on any type of files. And you'll see that the outputs, I get actually a mix of SOLIDWORKS parts that came out in the result, in the search result. So that's the cap going on top of the caster. But I also have Inventor results. So I got my Inventor files inside my PDM system. It actually found this file because in the Inventor properties, I actually have the word caster in here. So that's how it found it. I got a preview. So even though this is a Inventor file, I can actually preview it. I can measure on it right inside my PDM system. So this is just telling me that I can manage, any type of files right inside of PDM. We'll get back to that. So for now, I just want to insert this caster assembly. I'm going to say open. This is going to bring in the Inventor assembly back inside SOLIDWORKS, but it's not, again, it's not doing a traditional import and converting the files. It's actually just opening the Inventor files inside my SOLIDWORKS assembly. So that means that this is still referencing the original Inventor files. So I want to, mate it to position, control select, use my quick mates to make that, concentric. Also, if you might have missed that in 2019, a nice little enhancement that we added in 2019 is that when you mate parts together, and you want to select through a component, you can actually use the Alt key to hide faces and select other through the part. So here I got a machining feature where I can actually sit that into. And if we want to take a closer peek at this, just to make sure that we've done this right, let's just create a section view real quick. And you'll see here, I just made this Inventor subassembly inside my SOLIDWORKS design and made it coincident using some of the mating techniques. Now I've got this caster assembly on one side. I do want to create a copy on the other side. Now you might want to kind of go for a symmetry, but this is actually not symmetric. So I'm going to use a copy with mates. So copy with mates allows me to simply grab a subassembly and simply say, hey, I want to make this new subassembly, create a copy, make it concentric to this mount here, but it's going to be on the same coincident plane. So I'm going to simply hit repeat for that. And very quickly, I've created a copy and mated it into position without having to, resort to the traditional method of, copy the whole, subassembly and remade it all together. So very quickly, I was able to do that. Now, what happens using 3D interconnect inside of SOLIDWORKS is that it actually keeps looking for the original inventor files, referencing these files. So for example, let's say I have a change inside of inventor, and this is a good example where we've had someone come in and change that subassembly to make the post a little longer, add the wheels. What happens inside of SOLIDWORKS? So we're gonna actually replicate that through the PDM system. So if I go in my caster assembly here, I'm gonna look it up. So this is the original one. If I look at my history, and that's one of the beauties of the PDM, is that it captures everything in history. So I see here I have two versions, and the second version was just updated with a new design where there's the wheels and a longer shaft. So I'm going to say I want to get this version and hit the get, close this. The preview updates. So you see here I got a new version of this inventor subassembly. So we're gonna replicate how that would work inside of SOLIDWORKS. So if I go back inside of SOLIDWORKS and I do a rebuild, SOLIDWORKS will actually see that there's been a change in the original inventor file. You can see that with the little rounded arrows on my items here. So from here, I could simply right click and say I want to update the model. And basically what SOLIDWORKS is doing is refreshing this model inside of my SOLIDWORKS assembly. Now the beauty is I don't need, nothing's broken. My mates are still working. This is still mated in place. Everything works well. So basically, using 3D Interconnect inside of SOLIDWORKS, it basically reacts much like any other, SOLIDWORKS subassembly. So this is a great way to bring in data from other CAD systems. So here I was, using an example using inventor files, but we support Solid Edge, PTC Creo, CATIA V5. So even neutral file formats are supported through 3D Interconnect. Now, I want to do a change to one of these files, and actually I'm going to do changes to two of the files. One of them, I want to actually recreate the parametric sketch and features so I can do some changes with the dimensions. So I'll get back inside of SOLIDWORKS for a quick sec and see what we're going to be doing next. So if I put the section view back up again real quick, just to zoom into that area, we notice that because we updated the caster assembly, that caster assembly has a longer shaft, and we can see it's protruding through the cap. So there's obviously an issue here. So I need to change this part here to make it fit right. So I'm going to simply open this part. Now, as you can see, this part came in from another system. It's an imported file. There's no features, but I do want to make some changes. So one of the methods we can use is actually use SOLIDWORKS or FeatureWorks built inside of SOLIDWORKS standard. If I select any of the faces, I say I want to edit the feature. What's going to happen is that SOLIDWORKS is going to actually recreate or reverse engineer this file to create a sketch and to create the feature that needs to be done to, as if you would have modeled it right inside of SOLIDWORKS from the get-go. From here, I could simply say I want to fully define the sketch, click OK. You see I got all my dimensions in the model as well. So everything is basically like remodeled as if it was done inside of SOLIDWORKS originally. I'm going to close that and save it so we can get back into the assembly and continue my changes into the assembly. So as I come over here, let's edit the sketch. and do some of those changes right inside my assembly. So first of all, these two dimensions here, I don't really need, so I'm simply going to delete these two. And I'm going to add a dimension to this sketch entity here. So just select the line, add a dimension. I'm going to keep the original dimension without doing any changes. But what I'll need to do is make it a little longer. I actually want this to be snug right with the actual bearing face here. So what I'm going to do is Control select the line and the edge, make that collinear. So it moves right over here. As you can see, the sketch moved. As I exit the sketch and rebuild the part, what you'll see is that even the mates of the cap is all going to still continue to work. So because the cap was mated on the top face moved, everything works well. And because these are actually two of the same parts on each side, both of them are updated correctly. So using SOLIDWORKS, we can actually do some refeaturing. So even though you imported files from another system, we can easily use FeatureWorks to reverse engineer the file, create the sketches, the features, and reuse that. Now, another way we can work with files coming from other systems is that, in often cases, you don't need to have access to all the features. Maybe you just want to take something, make it a little longer, make it a little shorter, plug a hole, create a new hole. So some of those features don't require you to have a fully modeled part inside of SOLIDWORKS. Here's an example. Back to my assembly, I want to shorten the, remember one of the tasks was to try to shorten this frame here to make it as compact as possible. So let's go ahead and open this part. As you can see, this is also a imported file. And kind of a neat trick here is that this is actually still referencing the original inventor part. That means that if there's a change to the original inventor part, I could actually bring that change back into that SOLIDWORKS file. Now for this example, the only thing I want to do here is make this frame shorter. So I'm going to use some of my direct editing tools, again, inside of SOLIDWORKS Standard. Window select the faces, and I say I want to make that a little shorter. So I'm going to use an edge as the direction and say I want this to be maybe 50 millimeters shorter, about 2 inches or so. I got a nice preview. I click OK, and there it is. I've just shortened the frame without even creating any, even though there's no features like parametric features, I can still do changes to this file. Let me close it, come back to SOLIDWORKS. And as I head back into SOLIDWORKS, everything has updated. It's a little shorter, but maybe I want to, see if I can make it even shorter. Again, a design that's even compact. So here, because I actually use a move face command, if I double click, I do have access to the dimension of this move face. So let's say I want to try to, it's about 2 inches now. Let's try 4 inches and hit rebuild. So right within the assembly now, I can actually do these changes and see if it works or not. So a 4-inch, make it shorter by 4-inch looks like a good design. I'm simply going to accept that. And my design is complete. So let's just go back to the full assembly. And at this stage, I'd be done doing some changes to this design. Now, I've done a couple of things. I've added components from another system. This time, well, the first time around, the wheels were from Inventor. There was a change in Inventor. I updated that change back inside of SOLIDWORKS. Then we opened a file that came from another system, recreated the features, and this time around, without having to recreate the features, I just took something, again, coming from another system and made it a little shorter. So we can really quickly manipulate all these files, even though they are not a native SOLIDWORKS file, we can still manipulate them fairly easily. Now, the next question is going to be, how do I manage all these files? Now, again, from the beginning, I mentioned I'm using PDM to manage all my files, my revisions and versions of everything. But PDM is also a multi-CAD system, meaning that it can manage files from other CAD systems. So let's take a look at that. So heading back to SOLIDWORKS, I got my full design, and if I expand my PDM professional pane here, I want to, I'm done with the design, so I'm going to do a check-in, basically releasing the design. Maybe later today I'll send it for approval or things like that. But for now, let's just say I've completed my changes I was tasked to do. SOLIDWORKS reads all the references and all the changes to the other parts and understands that, I've made changes to the frame. If I expand the frame, you'll notice that I have this tube here that we changed. We also changed that frame rail. But if you notice closely, it actually reads references from even inventor files. So it knows that now there's a caster assembly. That's the sub-assembly in that same caster. I got previews for everything. And if you, again, take a look closely, you'll notice these are the original inventor files. So IAM, IPT. So those are the original inventor assemblies and parts. So SOLIDWORKS actually understands the references between these and my SOLIDWORKS assembly. So as I'm done here, I'm simply going to add a comment and say that I added wheels and shorter frame, and say I want to check these in. And actually, I could actually just close everything as I do my check-in. Now it's checking all of that data back inside my PDM, creating a new version with a history of all those changes. And if I look inside my PDM, which is nothing really more than Windows Explorer, so it's a Windows Explorer system, but it's really Windows Explorer on steroid, I should say. When we select any of the components, either the SOLIDWORKS parts, assemblies, or even inventor documents, I got the information on that. I also have the preview that's actually being generated down the bottom now because I selected the top assembly. So you'll see the preview of that in a sec. There it is. So that's a full 3D preview that's accessible for everyone, and we see that the latest change to that. What's great about PDM is that it tracks everything. So I got all the information about this file. I even have a little comment down the bottom of my last changes. So I know exactly what's been done lately. I have a contain, so I can see everything that's inside that design, including all of the inventor parts, sub-assemblies. They're referenced basically pretty much like any SOLIDWORKS sub-assembly would be inside the tree here. Now, what's great as well is that I could actually create a bill of material from here without having to do any drawing. So from here, I could simply say, hey, I want to create a bill of material. Maybe someone in purchasing needs to get a quick look at all the components so they can order all of these ahead of time. So very quickly, I got a bill of material created right from my SOLIDWORKS assembly without even having to create a drawing. So it actually created that bill of material right from my assembly, and including all the inventor components in here with their description, their quantity, their part numbers. So even though these files are native, again, native inventor files, we read all the information within the inventor part file and the assembly files. The properties, part numbers, we'll calculate quantities, obviously, and all of that. So very easily, I can manage all of these designs right inside of my SOLIDWORKS assembly. So PDM is really a multi-CAD tool. I could put in, a mix of inventor parts or assemblies in PDM. Creo is supported, Solid Edge is supported as well. So I could just drop those in PDM and manage revisions and versions right inside of PDM. And as you see here, this is a good example. I got actually a SolidWorks assembly that has a mix of different CAD files coming from other system, all managed inside of SolidWorks PDM Professional. Now, the last thing I want to talk about is beyond CAD. So far, we've mostly concentrated on CAD, a little bit on data management, but there's a lot of things you can do with documents coming from other 3D CAD systems, even if they're not native to SolidWorks files, to SolidWorks. So, for example, quick look into some of these tools: simulation, SolidWorks CAM, SolidWorks Visualize, and SolidWorks Composer. So just quickly, so for example, SolidWorks simulation, we don't need a native file. We can just work with any imported data. Here's a little gear coming from Pro-E, from Creo, and I've done a simulation on it. Again, I just need the geometry. I opened it using 3D Interconnect. Again, with 3D Interconnect, if there's a change on the native geometry, the native Pro-E file, I can simply update that inside of SolidWorks. Now the simulation tool, because we're doing FEA analysis, is going to warn me that the geometry has changed, but everything still works. I don't need to redefine the forces or the fixtures. I can simply rerun the simulation and update my results based on this new geometry. So here I'm simulating a gear locked with a keyway on a shaft, right? So even though this file is actually a native Creo file, I can do simulation inside of SolidWorks. Here's another example using SolidWorks CAM. Again, SolidWorks CAM doesn't care so much about the features, if they were modeled inside of SolidWorks or not. It cares about the geometry. So with SolidWorks CAM, I run my CAM setup. It's going to actually create those machining features by itself. Then I can go in and do some manual definition of those machining features, and then run and simulate all my toolpath and simulate that right inside of SolidWorks. Again, this file could have come in from another CAD system. We just need the geometry. Now, this example here actually was a native SolidWorks file, so I could change the dimension, but even if the file had changed in the native system, using 3D Interconnect, the geometry would update back inside of SolidWorks, and SolidWorks CAM would understand that there's been a change, prompt me to update the toolpath, and I could resimulate all my machining simulation. Another example here using SolidWorks Visualize. Now, SolidWorks Visualize, by difference with simulation and CAM, lives and breathes in its own window. It's not embedded inside of SolidWorks, but it can open, obviously, SolidWorks files, but it can open about 20, 25 different other file types, including files coming from a native third-party CAD application. So even though I'm working maybe in Inventor, I could open this file inside of Visualize and now start painting the file to create some high-end rendering, some photo quality rendering. So I can play with my cameras, paint the model using different textures, play with the textures, set up a depth of field, work with my lens, camera lens, and create even animations and really create some high-end photo quality rendering using SolidWorks Visualize. And maybe another tool, again, that is basically CAD neutral is SolidWorks Composer. SolidWorks Composer is a tool you can use to create instructions, any type of technical documentation. assembly instructions, work instructions, repair instructions, user manuals, parts lists. Here's an example, a little bit as a use for marketing presentation type of documentation. But again, Composer is its own system file, if you want. It doesn't need to work inside of SOLIDWORKS. It works as a standalone application and can also open 20-something different file types, including files from other third-party CAD systems like Creo, for example, and create all of those instructions, either work instructions, presentation, everything that's technical in nature that you want to document. Composer is a really great tool to do that. So as you can see here, using SOLIDWORKS, you can still leverage a lot outside of SOLIDWORKS. So for example, you can still leverage that CAD data that's coming from other CAD systems into other aspects, other areas, or other applications of SOLIDWORKS or something similar. So we talked a little bit about simulation, CAM, photo rendering for sales and marketing type content, and even Composer for assembly instructions or something similar. So if we wrap up a little bit what we've kind of covered today, so we use 3D Interconnect to bring in components from other CAD systems without doing any translation. We then took that, one of the parts and refeatured it as if it was a native SOLIDWORKS file, but we basically reverse engineer it to create the sketch and the feature. We then opened the frame, part of the frame, and just made it shorter. Even though there's no features, I can still move face and use some of those commands just to do some quick changes. We saw how PDM supports all our data, even if they're SOLIDWORKS or other file types. It understands the references, you see them in the bill of materials, so everything is really nicely supported. And then, there's also a number of areas where you can repurpose the CAD files from other systems for something else, rendering, machining, simulation, instructions, things like that. So that kind of wraps up a little bit my presentation, or what we wanted to cover today. The recording is going to be hosted on our channel along with so many other recordings. We have a lot. We actually, it just popped to mind that we actually did a presentation a little while ago on 3D Interconnect. So if you want to learn a little bit more how 3D Interconnect works, you can kind of browse through our recordings and see the session. And also, I mentioned actually that I was working in 2020. There's a lot of enhancements in 2020. I showed two, one inside of SOLIDWORKS, one inside of PDM. But I really encourage you to reach out to your resellers and look at the rollout events. All of the resellers are doing, within the month of October, November, they'll be doing rollout events. Some have already started. So I really encourage you to reach out to your resellers and take a look at these and come and see SOLIDWORKS 2020 for yourself, and all the other hundreds of enhancements that we've put into the software. So Joelle, I think it's going to be up to you.
Up to me. Thank you, Michel. All right. So as always, great information, very clear, very pertinent. So appreciate all of that you've shared with us today. Just a quick reminder of some of the reasons why you're moving away from a CAD or into SOLIDWORKS, working or concentrating on a unified platform to help boost productivity, reduce costs, improve quality of your products, foster collaboration, and increase innovation. All great reasons. If there's any of these objectives that are on your forefront and you're not quite sure which direction you need to go, and you'd like to explore how and if SOLIDWORKS can can help you, then please either reach out to us or indicate this to the reseller who's going to follow up with you, just to see if you have more questions and to see if there is the next step. And from that, then we can investigate further specifically for you how SOLIDWORKS, the tool, the platform, the people, can help you improve all of these aspects that we've talked about. So with that, we're going to give you 15 minutes back on your schedule that we had kind of reserved for this, and hope to see you on another webinar, and definitely share this one if anyone else within your company should see it. We'd love to hear from you and see how, if and how we can help you. With that, wish you a great day, and thanks, Michelle, again for all that great info. Bye for now.
Thank you. Bye.